This is Will Monahan from CS6963. I am speaking to you today about the Digital Fingerprint project. A little bit of background on why the project was done and what was actually accomplished. First and foremost, humans are creatures of habit. My first forensics investigation about 12 years ago, we noticed that the alleged perpetrator had the same habits, or at least I noticed that the alleged perpetrator had the same habits of websites that they would visit on a daily basis. They'd roll into work at 7 o'clock and visit sports page and some other sites, but it was the same thing over and over and over again. That's when the individual said, well, it wasn't me. We pretty much knew it was them. Fast forward to today, the smartphone technologies that we have today are very, very, very complex, whereas humans are very, very, very unique. So the thought was that if we can gather artifacts off of a smartphone and look at the apps that have been downloaded or the websites that have been visited, or perhaps even the texting, the way the person writes texts, we could actually create a fingerprint for the person. And the reason smartphone technology was selected, or the Android in particular, was because we are living in the post-PC world. Of the 1.7 billion computer devices that were sold last year in 2013, 1.4 billion of them were either smartphones or tablets. So for e-discovery activities, we already live in the world where more often than not, if you're in a crime scene, you're going to find a smartphone or a tablet as opposed to a computer. The experimentation has two parts. The first part was the acquisition of electronic evidence off of two smartphones owned by the same individual. We had a Samsung S4 and a Samsung S5. The details of both of these phones are on the screen, the serial numbers and other information. We did a logical acquisition, not a physical acquisition. And what that means is that information was harvested off the phone. What was readily available off the phone was gathered off the phone, which included, but is not limited to, the apps that were downloaded, browser bookmarks, call logs, the contacts, the text messages, people contacted, phone numbers, things like that. But the material was gathered in such a way that we didn't have to look at erased files or anything obtrusive. It was just pretty much gathered from built-in functionality on the Android operating system, which allows the apps to share information with other apps. So with that thought in mind, let me go ahead and I'll get started with the acquisition. The operating system that was used for the acquisition is Santoku. Santoku is the word for a knife in Japanese, and it's a distribution of Linux. It's Ubuntu 64-bit, which comes prepackaged with a lot of the mobile forensics tools. It was almost perfect for the work that was done with the Androids. Everything was prepackaged, the software developer kit, Java, everything that was needed. So it was really easy to set up, and it's free and downloadable. So it worked very, very well. For this, what I've done is I've hooked up the Samsung S5 via USB cable, and I'm going to walk through the acquisition of electronic evidence off of the Samsung S5. So the first command that you see here is on the screen, ADB devices, and that is essentially the Android debug bridge, which gives us the information about the Android phone that's currently attached. In this case, here's the information on the phone itself. The next command that I will type is ls usb -v for verbose, and that command will give us detailed information from the USB port about the phone itself and there it all is. Not much of evidentiary value, just pretty much overview of the phone itself. The way the information was harvested off of the phone was via dropping an applet onto the phone itself and then having that send the information back over. So there's a free open source app that you can install. It's called Logical, and Logical will again through the Android operating system, it's pretty well sandbox the apps, but apps share information with other apps, and what AndroidForensics.apk will do is it'll be an app on the phone itself, and it will gather information from the other apps and save it to Excel files. So let me go ahead, I'm going to install that on the Samsung S5. Success. So it's on the phone itself. Because you cannot see the Samsung S5, what I'll do is I'll pull up a screenshot of what it looks on the phone. So this is a picture, of course, of a smartphone. On the left-hand side, the apps that are listed, and this one that the mouse is on is actually the app that was installed. On the right-hand side, you see the different options for gathering information off of the phone itself. So you run the app pulls information off of the phone and saves it in Excel spreadsheets, which we're going to use to analyze for the digital fingerprint or the habits that the individual have. If we have a digital fingerprint or something close to it for a human, it can be used for target marketing, or perhaps even finding someone who doesn't want to be found, an interesting individual. And the thought is that many people who don't want to be found are using burner phones. They use phones for a few days and throw them away and get another phone. That being said, if we have a digital fingerprint on the individual in question, just by the downloaded apps or perhaps even some of the text messages that they send, we can start locking in on who's actually using that phone or who that phone belonged to. So let's go ahead, I'll show you some of the here's the forensics folder where the Excel spreadsheets were downloaded to. I am going to minimize Santoku and take you to the Apple operating system and walk you through a couple of the Excel spreadsheets and take you through the statistical software. This is a Macintosh, of course, running Fusion 6 and rock solid with the Ubuntu operating system. So under the Samsung, I'll take it to Samsung S4. Samsung S4, this is what the Excel spreadsheet looks like for the SMS messages. And these are the messages themselves. And for the statistical analysis, we have a wealth of information to work with, as you see before you. Probably the most challenging analysis was for the text messages, because we have to do an analysis of the words that were used in the text messages, whereas browser bookmarks or apps that are downloaded, those, statistically speaking, are not that difficult to correlate with another individual. But the SMS messages, essentially, we were looking at the writing style and the words that were used by the individual to determine statistically if it were the same person. And I'll show you how to do that here in a moment. So there are roughly 29 files that were gathered via the forensics app and brought over, and we're going to focus in on SMS. Now, in order to do that, we have two SMS files, one for the Android S4 and the other for the Android S5, and that's really not enough to work with to do any kind of statistical analysis. There are some sites on the internet where you can download thousands of messages. And just to keep this easy, I'll show you some of the random text messages that I pulled up, which this one is pickup lines off the internet, and this other one I think was jokes off the internet. So we had the Samsung S4 and the Samsung S5 with legitimate text messages from the same user, and then we added these two text messages or sets of text messages to see if our analysis proved that both Samsungs are related, whereas these other messages are not. So let's go ahead and start the statistical analysis. The software that was used for the data mining or the statistical analysis is RapidMiner. So I'm going to go ahead and go back up. Go back to the design view. And RapidMiner was chosen because it's really, really, really easy to use, and it's very, very, very powerful. It's open source, and what the first step in the process, it's literally object-oriented statistical analysis. So the first step in the process was to download the text processing module, and that doesn't come standard with RapidMiner, but all you have to do is go to the help and update the extensions and pull it down, and it's free, so it didn't cost anything. So text processing was pulled down. The first block that was included was process documents and files, and there are 4 files in here. One text file from the Samsung S4, one text file from Samsung X5, and then the 2 random text files. I'm going to open the block up, and inside you see tokenize and transform cases. And tokenize is essentially separate the words. So if there's a dash between the words or some other punctuation or whatever it may be, it'll just break everything up into words. Transfer cases is exactly what you think it is. It transfers everything to lowercase. So not only did the block read those 4 files, but also it tokenized and transformed the cases on both of those files. Okay, the next step was data similarity, and this is kind of interesting. And this is not a statistics course, but let's just talk about it for a moment. In order for us to determine as to whether or not the same individual wrote the text messages, we have to do an analysis of the words that were used. And in this case, there was a statistical model or statistical design that was used, and it's actually frequency inverse document frequency. What it will do is it will look at the word, and if the word is common in all of the documents, the word will not be considered significant. However, if the word is unique to 2 or 3 of the documents or a small subset of the population, then it will be counted higher. So if me as a user, if I use the word boat in my text messages all the time, and we have 4 files that we're working with here, but if the word boat comes up in 2 or 3 of the files, then depending on the frequency, it'll be weighed differently. So it's actually a very good way of determining if a word is important to us. And of course, there are a lot of words in the English language or other languages that are very, very, very common. Those words are ignored because they were pretty much in all of our text messages and all of our files. So, and not to get into the details on it, but the frequency inverse document frequency, or it's often referred to as TF-IDF, scores the messages. So us as humans, sometimes I'm predisposed to use one word more than I use, or use it very often, whereas other people will not use that word very often. And that's what it's locking in on. So let's go ahead and we'll run this and see what comes up. Okay, again, there were 4 files. The random text, the Samsung S4 is ID number 1, the Samsung S5 is ID number 4. I'm going to click on similarity measurements, and you'll see that 1 and 4 had a 0.868 similarity, which is very, very, very high, whereas the comparison between the other, 2 and 3, 3 and 4, and 1, 2, as you'll notice, are very low. So the statistical analysis of the text files, the SMS messages that came from Samsung S4 and the Samsung S5, there's a correlation. That in and of itself would not be probably enough to prove that it was the same owner. However, taken with the apps that were downloaded, taken with the websites that were visited, taken with perhaps even the phone numbers that were in the system or on the smartphone, add everything together and you'll have a very good fingerprint of the individual in question. So just as a quick recap, Santoku, a 64-bit version of Ubuntu, was used to acquire 2 Android phones. It was a logical acquisition. Apps were installed on both of the phones, which gathered information from the various other apps around the phones and brought it over in the form of Excel spreadsheets, roughly 29 Excel spreadsheets. From those, the experimentation focused in on text messages. So in the case of the Samsung S4, these are the text messages that were sent on the S4. 2 more text files were included just to prove that the Samsung S4 and the Samsung S5 were related. The Rapid Miner software was used to do the statistical analysis. It's open source, object-oriented software, which is very, very, very powerful. The design was created and it was run. Thank you very much for your time, and I hope you have found this to be informative and enjoyable.